Couple things to consider here. This is the positioning here that I was talking about. Kind of hard to see it at that angle, but I can move this out to, you know, there. That's good, 1/16 of an inch. Okay. Something else I'm going to do too, since this is a floating caliper, the sleeves here, the whole caliper rides back and forth on these sleeves, and the bolts hold the spacers, the sleeves, tight to the bracket. Okay, so what I'm going to do is I'm going to see if I can't put the air nozzle in here and clamp the caliper down. Okay, and what that'll do is this distance up here from the pad to the front, okay, that will not change. Now, granted, I may want to put a bit of a spacer in there just to give myself a little room. This should be enough. That way I'm not hard tight up against it and any error starts making it. I put a machinist scale in there. That buys me a little bit of playroom, and I don't have to worry about, you know, if I buy a different brand of pad. It's a little thicker kind of thing. So let's see if the caliper will clamp. It does, but can you see that? It's you can see it go up and down. And what's happening is the square cut seals, O-rings more or less, that are around the piston, sealing it to the inside of the bore there, they deflect. And so unless I went a lot farther, it basically they go out and then they pull the piston back in, and that's what helps to keep the pads from rubbing while you're driving, you know, and dragging. So I'm not going to gain any more there, and honestly, that extra space there isn't much more than I put on top here. So maybe I'll find something slightly thicker than that scale and put it in there and see if I can't get that actually a little bit more centered. So this one is just a hair thicker. It might not be thick enough. Oh man, it looks really nice. Well, all right. I'm holding it down here so that sits flat, okay, because the weight is going to pull it down under a bit, okay. So if I hold it like that and then I put this in there, I have got a hair more on the front side than I do on the back. And honestly, I kind of want it to default to the back. So since it's so close, I am going to Yep. I like that. Got good clearance there. Okay. So that takes care of getting it centered this way. I want to get it moved out just a hair. I think that'll be okay. I may need to play with that adjustment. I may have to, you know, print it once, whatever, create whatever kind of jig, bolt it all together and then see. But what I'm going to do while I'm here, whoops, I am going to, and that's probably the vise I'm hitting there, because it's definitely not hitting the hub here, the rotor top hat. So, oh, it's hitting inside here on the rotor. Okay, so let me see if I still have the stuff I used to use. I'm using the rotor as an anvil. I know it's not shaping it to it. Okay, so now I can give it a little bit more massaging. Okay, that's pretty darn close. Okay, so let's put our... And the rotors are cheap, you know. If I screwed one up too badly, I'd survive having to buy another one. Okay, so I have got the plumber's strap, and it's a little bit thicker. It's not the really lightweight, flimsy stuff. It's 30 thou thick, probably. I'm guessing. I don't know. I could measure it, but I don't care about having it a lot farther off. And like I said, I can adjust it after I get a measurement. But I do have a nice spacing here. So I think that's actually perfect, because a lot of times the rotor has a chamfer, okay? And I like to have the pad inside that chamfer, not going off the edge of the chamfer, because then it creates a little fine piece on the outside there, and tendency to make noise. So anyway, I can, oh, not long enough. I guess the pencil is the better option. We've got the spacer under there to keep it up and down this way, the spacer in there to keep it just off the rotor there. I'm holding it flat. And okay, one hole. Okay. Oh, let's and I put a couple of magnets there on either side. Oh, ouch. As you can see, I got the quick clamp on the other side here, because with the caliper hanging here, I'm clamping two flats on a round, and it didn't want to, there was a chance it could have tipped, because I can't clamp it too hard. I don't want to squish that. All right, so let's just turn it over. There's one here, and there's one there. Oh yeah, that shows up pretty good if I zoom in a little bit. Yep, there's the other one. So next step then is, this is over 6 inches. I could, maybe I'll pull out the bigger calipers. I need to measure that bore. Oh, although I could get an accurate measurement on here. Oh yeah, let's. I paid pretty good attention to getting this rotor clamped centered when I bolted it down to the hub. So what I should be able to do is I can measure from the center of this hole to the edge of this. Actually, what I can do is I can go to the end of this. That's a machined surface. So then I can measure that diameter, add it to this distance. I can take half of that diameter, add it to this, that's the radius, and then in CAD I can draw a circle there that's perfectly concentric with the center of the brake bracket. We should be good to go. That'll keep my rotor nice and centered. So I got 2.357. 2.357. 3.38. Oh, you know what? 3.375. 3 3/8. I think I might round that other one up to 2.36. 4.55 is 4.5 plus another 50 thou. That's radius. Okay, so I don't want it pushed out or pulled in. I don't want to pull it in 50 thou to try to get that to an even number, and I don't want to push it out that far either. So I could go to 4.55, call it good. That would be close enough. Now, like I said, the hub is going to be Imperial, but the rotor and stuff should be metric. All right, there's 4.55. And just eyeballing it for a sanity check, I'm on the center of this one. And man, that looks nice there. So one thing I wanted to do, meant to do it before I moved it, but let's put it back out here to the 4.55. That's 71 1/28. That's a little ridiculous. Okay, so 115.6. If I take it to 116, that would probably still float. And if I took it down to 115, this is millimeters. Yeah, either one would be fine. I think I would tend to make it the 116. Realistically, I'm still going to be doing it in inches. I was just curious whether or not there was a metric that put me even closer, an even number. When I'm working with the Datsun stuff and the hard body stuff, I do that in metric. Not this. I don't like to have metric and imperial mixed because, then I lose track of something. And, yeah. Anyway, so I'm kind of excited about that. The other thing too I wanted to check, and I said I thought it was going to be 5 3/4, so it still could be. Well, 5 3/4 does look pretty damn good. So I'll double check what I found before. I'm going to make this center hole, yeah, so 2.5 is just big enough. If I go to 2 3/4, then I could make that bracket bigger. Oh, hey, while I'm here, let me show you this. All right, so with all the yakking I was doing about, making a boss, making it thicker as it goes down in there, that's exactly what I did with these. This adapts an old Datsun drum brake truck to hard body, newer Nissan discs, okay, and this is a scrap one. Anyway, so as you can see, in order to get it a little thicker and more, reinforced around here, well, that hole's not big enough to go down in there, but the spacing's not bad there, but you can see that I got that top hat more or less down inside the rotor to beef that up here. And then this is the same thing. That's for hub clearance, okay? But this will clear the boss on the spindle, and then this will clear the back of the hub and basically help keep that a bit thicker too, okay? So I could do that. I would not do that if I decide I'm going to make it just, have 3/8 inch brackets laser cut. And if I do the brackets, I could have pilot holes drilled in the bracket. I don't think I have any. I don't think I have the steel ones anywhere around. On the steel ones, since it would have been a much bigger pain in the butt to cut these out, and I did the steel prior to getting the CNC mill. Okay, and so then I designed them in aluminum so I could machine them on the mill, and then I quit making the steel ones because you can't counterbore like this on a laser cutter or anything like that. I just simply made the holes bigger, and since it was 3/8 inch steel, I wasn't worried about the thickness or whatever. But what I did is they were pass-through holes on the steel brackets, and so I had those laser cut, and I didn't have to mess with them. Maybe a tiny chamfer around it, stuff like that. If I have the brackets cut in steel, I'll build a jig and I will drill these holes, or I may even, something. I don't want to have the holes laser cut because I'm going to thread them, and I'm also I don't want pilot holes cut in because the walls are hardened on a laser cut like that, and I would just be killing drill bits. So I'm going to have everything done and then not have the holes drilled. The mounting holes here on the bracket for this, they're going to be pass-throughs, so they're going to get laser cut. No.